Welcome again. Today, what we're going to do for our Fab Learning Real Talks Day is our first hour. This is a 90-minute session for participants, but for the first hour will be our open class with our real world talk. So we'll have a real world talk to begin with for about a half an hour. With a question and answer period in there, and then another one for about another half an hour. And then we'll ask our participants to stay on the line so we can go over the details of their next assignment. And those of you who are joining us from kind of outside our class can enjoy the rest of the day for yourselves. So thanks for coming and supporting. And I'm going to turn this over to Stephen to do our first intro. I think we have an intro slide.
Yep. Good morning, afternoon, evening. Okay. I'd like to introduce our first guest speaker for the real world talk. His name is Chong Kai. Okay. Now, Kai is the founder and CEO of Sikkim, and he grew up basically as a maker, tinkering with all kinds of gadgets, including air cannons, flamethrowers, and robotics and stuff like that since primary school. And one of the things that he noticed is that sets like the Lego Mindstorms, for example, they're pretty pricey. So he decided to make a STEM kit to make the STEM education more accessible and affordable for everyone. So he launched his company, Sikkim, in 2023, while, while he was still a student at the Singapore Polytechnic. And to date, the startup has reached over 12,000 students and teachers from across 11 countries and 95 schools. Okay, he's got a whole list of accolades. One of the youngest Forbes 30 under 30 Asia nominees, Philip Yeo Initiative, Agenti leader, and a whole lot of stuff. And in September, he actually won, his team, Sikkim, won the Global Hult Prize, which from a list of 200,000 student competitors across 130 countries. So without much further ado, let me introduce Kai. Kai, thanks for coming and joining us for the talk. Over to you.
Hi guys. Thank you, Stephen, for the very yeah. So hi guys, my name is Kai. Today I'm gonna do something a bit different. I'm gonna share a bit more about how Stickum started. Um, Keep in mind this pitch deck is usually used to explain to kids about how we started. So if it seems like I'm talking to kids at some point, it's because this deck is for kids. But I think it gives everyone a good idea of how we started. And then I'll talk a bit more about how we literally started everything in our first year using Fab Lab in Singapore Polytechnic. And then maybe you can open for questions. I might be the youngest one in this call today. I'm currently 22 years old, so probably the youngest here. So yeah, my name's Kai. I'm the founder of Stickum. For depending on where you are in the world, you might have seen us in the news recently. We won this thing called the Hult Prize, which many call it, I think it's a bit much. They call it the Nobel Prize for students. And we basically won $1 million in seed funding to help accelerate our impact. But yeah, you might have seen us for the Hult Prize. You might have seen us, if you're in Singapore, you might have seen us in the news. The Prime Minister was talking about us. We got Forbes 30 under 30 this year and a bunch of different publications. But, I'm not here to brag. I'm telling you this because just a few years ago, yeah, literally a few years ago, this was me. On the first day of primary 4, I got knocked out by someone. Primary 4, I think I was like 7 or 8 or 9 years old. I got knocked out by someone, had to go to the hospital on the first day of school. I can't even remember what I was doing to get knocked out by someone. So I was a really naughty kid. Growing up, I love building things. This is me and my dad building a PVC air cannon in my backyard. So I really, really love to build things. And I was always tinkering with stuff. Mostly dangerous stuff. I was using PVC to build knives, air cannons, tasers, flamethrowers, all sorts of dangerous stuff. I really hated studying, and I was always getting into trouble, and I could not sit still in classes. However, when I was in primary 5, something changed. I discovered this Singaporean charity slash NGO called Engineering Good. And what they did was they would take engineers and makers like me, and they would pair them with people with disabilities. So people who needed help tinkering solutions for them. And this was a very, very big tipping point because, yeah, I mean, this whole concept of using tech for good, assistive tech, I finally realized that my making skills from making like stupid and dangerous things could actually be used to help people. The whole idea of, yeah, tech for good really, really resonated deeply with me. So yeah, I continued to build things. I was always the youngest one there, teaching adults how to solder, teaching adults how to splice wires, all sorts of different tinkering skills. And although it took me 7 years, yeah, I finally discovered that my skills for building silly and dangerous things could actually help me to solve real world problems. So after I graduated at 16, very naively, I thought, okay, I want to change the world. What am I going to do? I'm going to teach more kids how to build stuff. So I'm going to work as a Lego trainer. I'm going to teach kids how to build Lego. And it was through this teaching, I worked at dozens of different schools where I realized that no matter what kind of school I was teaching in, international, government, gifted education schools, no matter what kind of schools I was teaching in, there were two big issues. The first one is that robotics and coding classes in general, regardless of where you are in the world, is really, really expensive, which means that it's really, really limited to middle to upper middle class parents and families. The second issue is that those families that can afford it, most of the time, maybe mostly in Southeast Asia, they send their kids there because they feel like it's going to give them a leg up in school admissions or for their workplace. The kids are usually not actually interested. Although I think with the profile of Fab Lab people here, you'll probably see very interested makers in your Fab Labs. But it's very different in these private industry robotics classes. So I thought to myself, okay, what if I could fix this? So I started to ideate, sketch a very simple idea: geometric connectors, wooden chopsticks, and a very, very simple, basically like an Arduino shield combined with a microbit. And the idea was very simple. We wanted to create an open-ended, low-cost STEM kit that will make kids more creative. So it's a very, very simple guiding principle, and we called it Stickum. So I'm a generalist. I can solder, I can splice wires, I can tinker. I cannot okay, I can do Fusion 360, but I cannot do anything that requires calculations or proper engineering. So I knew that I needed help. I got my kindergarten and primary school friends together, and I basically said, hey, can you help me design and print something? It's gonna take you like 10 minutes to help me design this. Jokes on him because he's still stuck with me 5 years later. And yeah, it was basically just me getting help from a bunch of my friends who were not specialists in the stuff I needed them to help with, but we all just learned along the way. So within weeks, we had a very, very simple prototype. You can probably see an Arduino Uno peeking through this. We took an Arduino Uno, we put a servo shield on it. We took like off-the-shelf servos, we printed casings. We basically created a very, very rough MVP. Did it work perfectly? It did not. It was honestly really horrible. But this horrible MVP allowed us to basically go to our parents, friends, kids and say, hey, can you test this out? Build whatever you can think of. Just, I want to see what you build with this. And they started building, all kinds of different stuff. Weapons, helicopters, solar systems. Honestly, they were building all kinds of stuff. And yeah, this was our MVP. And as we went to more parents, we also started to reach more teachers. And the teachers we talked to showed us that this was actually a big problem. Because firstly, I don't know about the countries you guys are from, teachers are super busy. Especially, there was this OECD report that came out recently for Singapore teachers that said they spend more time with administrative work than teaching, which is crazy to me. And the second thing is that schools usually don't have budget for expensive STEAM programs. I mean, you look at Vex Robotics, you look at Lego. Yes, you have Arduino, you have electronics, but how many teachers can really teach Arduino? It's a very, very limited amount, which means that it's either cheap and simple or it's expensive and simple. Sorry, cheap and complex or expensive and simple. It was very hard to find a middle ground. And yeah, it was like a lose-lose situation for everyone. And more importantly, this was not a Singapore problem because Singapore is so lucky already. We have so many resources. The schools have air conditioning, great maker spaces. If you look around just in the ASEAN region alone, there is already classrooms that look like this with no access to even basic materials. So what we did was we continued to develop the product further, and we basically created a hardware and also content for teachers to use in their classrooms. As makers, you might be thinking, okay, this looks like just a microbit and strawbees. I used to teach microbit, I used to work with microbit and also strawbees. And something I realized was that it's a great learning tool, but it's a bit too simple because end of the day, it's straws. So with that, Stickum started to scale. We worked with schools in Singapore. We went all around the world. We went to, for example, floating villages in Malaysia, rural outskirts of Vietnam, military-run schools in Thailand, Myanmar border, Brunei, India, all sorts of different countries. And what we saw was that the hardware we had created was easy to use, and it kind of allowed any kid to create anything they could dream of. Obviously, we wanted to reduce the starting point for creation and tinkering so that once they're more familiar with actually making stuff, when they grow up, they're like, oh, you know what? Let me make something a bit crazier, and then go to the Fab Lab or the makerspace to create things. That was the whole idea. Kind of like a better starting point for kids to get interested in tinkering. And this is slightly outdated. Our impact so far, we have reached 13,000 children, and we've trained 1,200 plus teachers. Not just in Singapore, but we've deployed this to around 11 countries, the furthest one being all the way to Uganda, where we literally send them the kits, we train them, and after a few months, they were able to rank #1 in the country to create their own robotics and coding club. So yeah, starting out, we did not have any official qualifications. We were literally a bunch of stupid, like 17-year-olds just tinkering, messing around and trying to figure stuff out. But by learning, asking questions, and partnering with different organizations, especially with Fab Lab, we were able to slowly learn everything that we had to know. And just like that, a bunch of 17-year-old kids and childhood friends managed to achieve the impossible. Okay, this sounds cringe because it's for primary school students. We were able to slowly but surely make STEAM education accessible to students and teachers anywhere. Not just, in rich countries, but literally anywhere. Obviously, we're still very early on. We're still scaling our impact. So luckily, the Hult Prize, the $1 million, really helps us to scale our impact. So this is my sharing that I usually do for primary school kids. I have made a deck for how we started in Fab Lab before. So I think I'm gonna share a bit about that because honestly, if Fab Lab was not there, like in our early days, we would probably be set back like 2 or 3 years. So yeah, I really love the whole idea of Fab Labs and makerspaces. So yeah, when we started, everything was failing, man. The prints were failing. The colors were not matching. Everything sucked. But it was a very basically safe space for us to iterate, fail, and develop our hardware solution, and get a very good sensing of what was working and what was not working. And luckily, in our Fab Lab, we had everything we needed to create Stickum. Literally, we had a sticker printer, we had a laser cutter to cut custom boxes. We had electronics available to actually test out the Bluetooth and everything. And even the more extreme examples, we had an embroidery machine, very fancy, expensive embroidery machine to create custom t-shirts. We had a laser cutter that could help us to cut the chopsticks to different lengths. We had access to a huge ton of materials, which allow us to create our first MVP. And yeah, I think if we did not have Fab Lab or the assistance of people in the Fab Lab, we would not be where we are today. And I really do credit a lot of our early success to having access to a Fab Lab. We would literally spend so much time in the Fab Lab. We would take up every single printer in the Fab Lab and just hog them like overnight because we had so many things we needed to print. But yeah, it paid off. Now we have our own office where we manufacture using like Prusas. But yeah, starting out, it was great for us and a lot of entrepreneurs that I see to basically create prototypes and start out on their founder journey. So yeah, I have stuff that's a bit more related to schools, but I think most of you are more makers than like teachers. So I think I won't really go through it. So yeah, any questions? Hope you guys haven't fallen asleep. Yeah.
Thanks. I will I'd like to, I don't know if it's really a question, but more of a reflection. I really
Mm-hmm.
appreciated how you talked about how you were making things, you were making knives and shooters and things when you were a kid. I know I've had this experience that probably a lot of educators in this meeting have had the same
Yeah.
experience where you have a kid who's just always trying to do something not quite aligned with the learning objectives, but very creative and obviously they've put some time in it. So it's really neat to see how you were able, or how your teachers, or how you're able to channel that into something good. But how did that actually come about? Was that something that your family found for you? Was that something that teachers at school made that
That's a
kind
great
of
question.
connection?
Yeah. So for me, the tipping point, because even right now we work with a lot of schools, like over 100 schools. A very common thing we see is that the school has a maker space, but they have this issue called like the keychain syndrome, where they're stuck making keychains, or they're stuck making projects that are so specific to the machines themselves. But you teach a kid how to make a keychain, and then what? So the tipping point for me was being able to see that, oh, these skills that I've picked up, tinkering and building stuff, could actually be used for more meaningful problem challenge statements, as we call it. That was the tipping point for me to go from just tinkering more like meaningless stuff to actually trying to build tech for good for actual people. So we try to do this at Stickum in the form of like simple challenges for students to just get them into the thought process. Um, but yeah, it's both you kind of have to force the students to think about these things instead of just, okay, you have a laser cutter in front of you, go make a keychain, or go and make a laptop stand or like a phone stand. Um, yeah, that's my thoughts on it.
The other question I have is using chopsticks as kind of the building material. How did that come about? And do you see, especially with your the Asian students, or the people that use chopsticks in their normal day-to-day activity, which we don't typically hear in the U.S.
Yeah.
Do you find some sort of is there some sort of cultural connection beyond just
No,
doing school
not
stuff?
really.
No.
No, the main reason we use chopsticks is because when I was thinking of the idea for Stickum, I want a low-cost building kit. My first idea was let's use cardboard because cardboard is widely accessible. You can cut it, it's cheap. But then I realized, okay, cardboard is pretty hard to build robots out of. You can, but it's much more difficult. So I was looking around my house for different parts. You have like plywood, you have like plastic things, all sorts of different stuff. And then I realized, oh, this is in Asia, specific to Asia. Like, oh, when you take away food, they give you like these chopsticks that you usually don't use if you're bringing it home. Because, yeah, you have chopsticks, but you have your fork and spoon at home. You're just gonna keep the chopsticks. It might be a very Asian thing. So I was like, oh, I have this huge stash of chopsticks that I don't use. What if I could build something out of this? Because chopsticks are quite strong. Like, they're pretty strong. And something interesting is that you can cut them because when you cut them, it means that now you can do customized things. It's not like, Lego or Vex where you feel afraid to cut it or it's very difficult to cut and customize. I think, yeah, being able to tinker and really customize things is important to me. That's why you see here that almost all of these have like paper, string, or like cardboard attached to it. It's intentional. We want kids to be using more than just sticker. Yeah. So not really cultural, more like, oh, it's a easy, cheap building tool. They're all brand new though. Recycled chopsticks that are clean and not and even are very hard to get. So we're just using new chopsticks for now. Yeah.
We have that here in Canada, because we have lots of Asian restaurants that make us throw away uh chopsticks too, and I use them too because some of them are great little stir sticks, and like we use them in maker
Yeah,
space.
yeah,
So I love them. I collect them. I tell people
yeah.
bring them in, do not throw them out.
Yeah, I mean, makers in general, like when growing up, I used to use popsicle sticks all the time. Popsicle sticks, skewer sticks. So I think that it's a pretty like natural progression to chopsticks. Um, it's not like a bizarre building, but it kind of makes sense, you know. Fun fact, I'm actually Canadian. The news keeps parading us around as a Singapore born and bred startup, but I was born in Canada and I moved to Singapore. Yeah.
Got a couple
Yeah.
Canadians on the phone on this call this morning.
Oh, cool. I'm from Markham. Yeah. Barrie.
I'm from where the mountains are in Alberta.
Uh, yeah. So yeah, if you have any questions about anything, let me know.
Does
Yeah,
anybody
usually
have another question for Kai? Or comment, really?
yeah.
Uh,
Yeah. We
hello.
always share with yeah.
Yeah, hello. My name is Frosty from Iceland. This is very inspiring what you're doing. Great. Thank you very much for sharing this. One question: have you thought about selling this as a, how to say, a kit where you can like produce it in the Fab Labs themselves, or like a distributed manufacturing? Is that?
Yeah. So long term, I think I want this to be kind of like in a way open source. I need to be careful with what I call it, but in some way open source so that maker spaces can make their own customized pieces. For now, we're still trying to figure out the business model for that. So what schools usually get is they just buy it directly from us as like a hardware kit. They put it in the classroom, and then the teachers will use it for all sorts of subjects. Let me show you some examples. So for example, if you are a Chinese teacher trying to do more hands-on learning, what the teacher will use it for is to build these like dragon boat robots. If you're an arts teacher, you'll build like toy puppets. So for now, most schools are just using it as it is. Although, yeah, I'm trying to figure out how we can make it such that they can kind of like a Tinkercad model where load it into something like Tinkercad and OpenSCAD, modify the angles or the number of limbs, and then they'll be able to actually create and print their own. Yeah, but if you don't have the tolerance down, it's quite hard to get it right, which is another like barrier to self-printing right now. Yeah, so this is something that we're trying to solve. Yeah, it'd be much easier if people can just print their their own connectors. Yeah, but it's very unlikely that a school has enough printers and enough filament to print a whole like classroom set because it's quite a lot of connectors. Yeah, like this. It looks like this. Yeah, so we also provide our own customized electronics board, which is like I'd say it's like a mix between microbit and the Lego brick, where it's just plug and play. Yeah.
I will say that these connectors that you kind of started with the concept of connecting sticks in a different way. To our Fab Learning Academy participants, this module, their assignment, their field activity is to design and build something that their students can use in a classroom lesson. And this is exactly one of those same things, right? Those pieces are designed and built and the kids use them in the lesson, but the kids don't actually 3D print them or design them themselves in the lesson. They're just using them as a tool or manipulative. So this is a really great talk for our participants right now, because these are the things that we're thinking about, like what can we make that our students can physically use in the classroom for learning. And this is a great example of one of those things. I mean, you've gone beyond what we're doing. We're doing one lesson and probably one or two manipulatives, but that's where you started, right? Is making one thing for students to use in the classroom.
Yeah, exactly.
And Stephen has shared the website on the chat, so if you guys are interested, thank you, Stephen.
Oh yeah, feel free to reach out, guys. I think one of our main advantages working with schools so far across all the countries is, I mean, the simplicity of it. It doesn't require a specialized STEAM teacher, which I think is a big issue for many schools because they don't have the budget to hire, or they don't even, in their region, they might not even have enough teachers that can run this kind of stuff. What we tell schools is that give us 3 hours, we'll turn every single teacher into like a STEM maker enthusiast. They will all build chopstick robots. They will all go hee hee ha ha and jump around and scream because it's so fun like this. And yeah, I think, yeah, at least in Singapore, the teachers are so tired and burnt out. So we're kind of showing them again that, hey, tinkering, making does not have to be very stressful and logistics heavy. You just need the right tools, which is stick 'em. Yeah.
So, Kai, what were the challenges that you faced reaching out to the schools, to the teachers,
Oh,
and was it easier getting the students excited, interested about it as compared to getting the teachers
yeah.
to give the opportunity?
Okay, honestly, students are very easy to impress and have them like learn. That one is easy. Teachers, having them build and actually experience it is very easy. You can see them jumping around and screaming like their inner child comes out. That's not the hard part. The hard part as a business is getting access to the schools in the first place, because schools are so busy, schools have limited budget. To get them to even reply an email is already so difficult. That's the main challenge. So if any of you are thinking about starting a tech startup that's in hardware, don't do it. It's very difficult. It took us 5 years to even get to where we are now, and it was like not an easy 5 years in terms of outreach. But yeah, it's fun. It's very fulfilling. Working with schools for us is quite easy because I think I'm very education centric. And yeah, once they actually build the robot, you see them instantly transform and their faces light up. But before like trying to explain the whole concept of making chopstick robots, that's a bit more difficult. And in many schools that we see, it requires them to actually build it before they're convinced. Because if not, they're like, oh, I'm not a STEM teacher. Why should I care about this? Why should I care about tinkering? That's something for the science department. That's something for the making department. That's not my job as like a English teacher. Yeah, but I mean, we're trying to get more teachers to just tinker in general. It doesn't have to be always robotics. Like we have teachers that literally they built like the Merlion, I mean the Singapore Merlion, or like the super trees. These are things that don't require electronics. It's just tinkering in general. Like this is like 90% not even stickum. But it's okay, you know, we just want kids to be building stuff. Yeah.
I have a question. You have been discussing about the curriculum, so you are offering also curriculum. What kind of things do you offer in the curriculum?
Yeah. So another thing we learn working with schools, I don't know if this is sidetracking, but something we learn working with schools is that teachers are not, okay, I can't say lazy. Teachers are so overloaded that they don't want to create lesson materials by themselves. They want something that's tried and tested and approved and aligned with their curriculum goals so that they can just plug and play it into their lessons. So very early on, we recognized this need. We created a ton of very fun challenge materials that are like, oh, assistive tech. Oh, this is exactly what I was talking about. I pivoted into a tech for good. I want more kids to be building tech for good. So I have this challenge. I have like a simple prototyping challenge. Build something to help someone escape from a well, or build a luxury backpack for your pet. You know, it's about building like fun stuff, serious stuff, silly stuff. Just getting them. For example, this is a very serious topic. Learning about unexploded ordnance in Laos, because in Laos there's a lot of bombs that are blowing villages up. We teach kids about this, and how we get them to learn about this is we ask them to make a bomb disposal robot. So we just keep sprinkling in like fun hee ha challenges and also very serious topics, so that you know you can't keep feeding them broccoli, right? You have to give them chocolate sometimes. So sometimes we coat the broccoli in chocolate and just feed it to them. We've seen it works. I mean, the teachers are happy, students are happy. Yeah. So yeah, we create lesson materials and we have it hosted on like a Airtable, where we have it all like on it's Google Slides and then on an Airtable. So you can click into it and you can just access it. Yeah. So we sell the subscription to schools too for like a pretty low cost. Yeah, that's our recurring revenue.
Yeah, this is basically what we have been discussing a lot here in Fab Learning Academy, that is learning through digital fabrication through tinkering. It's not learning how to do the tinkering, but you use the tinkering in order to learn other
Or something, exactly,
subjects.
yeah.
Yeah.
Yeah, it's difficult to explain to teachers the why. Like, oh, I can just teach them how to use the laser cutter, but why are you using the laser cutter? You know, what is the point? I think that's something that even in Singapore, it's like they're really lacking, at least in primary and secondary school. They still see making as like, okay, I'll come in, I'll learn how to use it, and then okay, I'll go study for my exams, you know. But yeah, you see here that we really try to push them to do random stuff, like, you know, football, Robot World Cup, Soccer World Cup, superhero fashion show, recycling trucks, like random silly challenges that they have to present about. It's just getting them to have fun making stuff again. We also like to do Maker Fairs. Maker Fairs is something that kind of died out in Singapore. So we're trying to revive this Maker Fair movement again because I think it's incredible, and more kids need to be making stuff within a day and like just having fun with it. Yeah.
I love that concept, one day maker fairs. Listen, it is time for our second speaker, but Kai, thank you so much. You've really inspired us. It was great to not only see your story as a student, you know, the types of students that we all have to deal with, into where you are now. That's a fascinating for us as educators, but also your view and your thoughts about education really fit into kind of what we're striving for here, which is using the technology to teach other content or to teach important content or sometimes fun content. So thank you so much for being here and sharing your story, and you'll get a lot of visits to your website, I'm sure, from this group.